Hello again, everyone. Welcome back to our course in trigonometry. In this video, I want to cover another identity. So we've started to explore these algebraic relationships between trig functions. In the last video, we talked about the reciprocal identities and the ratio identities. And the punchline there was, if you knew the sine and the cosine of an angle, then you could figure out the remaining trig functions using those facts. In this video, we're going to talk about the Pythagorean identity. So this picture here, I'm kind of going back to the concept of an angle in standard position and the way we would compute the trig functions based on this concept of an angle in standard position. Of course, we remember that cosine theta equals x over r, sine theta equals y over r, well, just for fun, I'll write down tan theta. Tan theta equals x over y. Okay, now the other thing I wanted to note is that there is a relationship between x, y, and r. If you look back to some of our earlier videos, you'll see that in the cases where we are given a point on the terminal side of our angle, we had to compute r using the Pythagorean theorem. Okay, there's a relationship between x, y, and r, and the relationship is pretty easy. It's x squared plus y squared equals r squared. It's coming from the Pythagorean theorem, right? This is the hypotenuse of a right triangle. That's also why these two trig functions can't be any bigger than 1. Okay, the hypotenuse is always the longest side. So if the cosine of an angle were bigger than 1, that's saying that this leg is longer than the hypotenuse. And that can't be true. So cosine and sine always have to be less than 1. Okay, so we know this relationship right here between x, y, and r. Okay, so let's consider this. Cosine squared theta plus sine squared theta. Okay, well, this is equal to x over r, quantity squared, plus y over r, quantity squared. Now, if you're squaring a fraction, you got to take that fraction multiplied times itself. And remember, of course, you multiply fractions straight across. So this would be x over r times x over r. You get x squared over r squared. This is y squared over r squared. To add fractions, you need a common denominator. Fortunately, we already have one. Both of the fractions have r squared in the bottom. So this is x squared plus y squared over r squared. But right here, we were just saying that x squared plus y squared is the same as r squared, so we can replace this expression in the top with r squared. So this is r squared over r squared, which is 1. Okay, so that is a relationship between sine and cosine. Sine squared plus cosine squared is 1. So the Pythagorean identities, that's the first of 3 Pythagorean identities. Okay, so sine squared theta plus cosine squared theta equals 1. Okay, first of the Pythagorean identities. There are a couple more versions of the Pythagorean identities. For example, if I were to divide everything by cosine squared, this would become tan squared theta plus 1 equals secant squared theta. If I were to divide everything by sine, this would be 1 plus cotangent squared theta equals cosecant squared theta. Okay, but this first one I want to think about a little bit more. There are a couple of equivalent forms for this. For example, you could solve for sine. Okay, if you want to get sine by itself, you'd have to subtract away the cosine squared. Okay, so you'd have 1 minus cosine squared theta. Now that would be sine squared, so we'd have to take a square root to actually get the value of sine. Now, when you're dealing with a square root, you're working backwards. When you square something, you always get a positive, but you don't know if you started with the positive version or the negative version. Okay, so to get sine theta, you can take 1 minus cosine squared theta, do the square root. To figure out the sine that you should use, you'll need to know where the angle is, what quadrant you're in. Very similar, we could solve for cosine. Okay. So this Pythagorean identity basically tells us that if we know the cosine, we can figure out the sine. Right? Because right here, if I know the cosine, do cosine squared, 1 minus that, do the square root. That'll get you the sine. If I know the sine, I can get the cosine. And if we look at the previous video, we said if you know sine and cosine, then you can get all the trig functions. So here we're saying if we know one or the other, then we can get the second one, and then we can get all of them. Okay, let me do a quick example here. Let's say if sine theta equals negative 1/3 and theta is in quadrant 3, find cosine theta and tan theta. Okay, so a little bit of thinking that I want to do here. If I'm in quadrant 3, let's once again think about an angle in standard position. Remember, we're looking at the positive x-axis, rotating in the counterclockwise direction, going into quadrant 3, so this is where theta lives. So cosine theta is negative in quadrant 3. That's important, because look right here. This tells me if I know the sine, I can plug that value in and get cosine, but how do I determine which of these to choose? Do I choose the plus or do I choose the minus? Well, since we're in Q3, choose the minus. Okay, so cosine theta equals negative square root 1 minus sine squared theta. Okay, so I take the sine of my angle theta, I square it. They told me in the problem that the sine was negative 1/3. Negative 1/3 squared, of course, means negative 1/3 times itself. Negative 1/3 times negative 1/3. It's got two negatives, so that's going to be a positive 1/9. Okay, now I know I just said it's a positive, right? But minus a positive, so this is going to be 1 minus positive 1/9. So negative square root 8/9. You're doing the square root of a fraction, you can do the square root of the top and the bottom individually. So got a 3 down there, square root of 9 is 3. Square root of 8, that can be simplified to 2 radical 2. Look back to some of our earlier videos. We do demonstrate how to simplify radicals. Remember, you have to think of the biggest perfect square that goes into this number evenly. Okay, the reason we're doing that is because we know what this is. Square root of 4 is 2. So square root of 8 simplifies to 2 radical 2. All right, so sine theta equals negative 1/3. Cosine theta equals negative 2 radical 2 over 3. How do we get tan theta? Well, we make use of the ratio identities. Tan theta equals sine theta over cosine theta. Negative 1/3 over negative 2 root 2 over 3. How do you divide by a fraction? Because it says we take this fraction, divide by this one. Well, you multiply by the reciprocal, so negative 1/3 times the reciprocal of that, the 3's would cancel out. 1 over 2 radical 2. If you rationalize the denominator here, I think you get radical 2 over 4, but I'm just going to leave it like that. I don't care about rationalizing my denominators. You can't tell me what to do. Okay, another thing to point out, the numerator is negative, the denominator is negative. The sign rules for division are the same as the sign rules for multiplication. So if you got two positives, your result is positive. If you got two negatives, your result is positive. It's only when you got different signs, one positive, one negative, that you get a negative out. Okay, so here we have an example using the Pythagorean identity. Okay, I'm going to do one more here. One more example. We'll use our identities and figure out every one of the trig functions given just one of them. Okay, so if cosine theta equals negative 5 over 13, with theta in Q2, find all 6 trig functions. Okay, I'm going to leave myself a little space to work things out. I'm going to write my answer down here. Okay, now they told us this one. Cosine theta equals negative 5 over 13. They want me to find the remaining trig functions. Now, one of these I can get for free. Cosine theta and secant theta are related by the reciprocal identities. If you know one, flip it, you got the other. Cosine theta is negative 5 over 13, secant theta, negative 13 over 5. Okay, I'm going to do a little bit of work here to get the sine function. I'm going to use the Pythagorean identity here. Now the version that I'm going to use says this: sine theta equals plus or minus square root 1 minus cosine squared theta. Okay, that's one of the versions of the Pythagorean identity. We just had them on the board. Now the question is always, okay, do I choose the plus or do I choose the minus? This lets me know what choice I should make. I'm in Q2. Angle and standard position, we're right here. Okay, there's theta. Y is positive, x is negative. If y is positive, that means the sine is positive, so I should choose the plus in this case. You got to look at where your angle terminates to determine whether you use the plus or the minus. Okay, now, they tell me that cosine theta is negative 5 over 13. So cosine squared becomes negative 5 over 13 squared. Now remember, this is always going to be positive, so you're always going to be doing a bona fide subtracting. You'll never have a negative and a negative in this formula. You'll always always be doing 1 minus something. Okay, so this is 1 minus 25 over 169. Okay, remember what we're doing? We take negative 5 over 13 times itself. The two negatives gives us a positive, and we multiply straight across. The numerator is 5 times 5, 25. The denominator is 13 times 13, 169. All right, so we're right here. Square root of 144 over 169. Okay, now how did I get that? Well, if we're going to do subtraction, we got to get a common denominator. We turn this into a fraction with the same numerator and denominator. It's 169 over 169. That's how we rewrite the 1 so that we can do the subtraction. Okay, so this becomes 169 over 169. 169 minus 25, 144. Okay. And square root of 144, that's 12. Square root of 169, that's 13. So sine theta is 12 over 13. So we were given this one. Reciprocal identity gets us this one. Pythagorean identity gets us the sine theta. Now we can get this easy. Reciprocal identity. Sine theta equals 12 over 13. Cosecant is 13 over 12. If you know cosine and sine, use the ratio identity to get tangent. Take sine over cosine. You take this fraction, 12 over 13, divide by this one. So you get negative 12 over 5. If you don't believe me, actually write out the two fractions. Remember, you're multiplying by the reciprocal. So you take this one times the reciprocal of this one. The 13s cancel out. If you know tangent, then you use the reciprocal identity and you can get cotangent. So we're given this and the fact that theta was in Q2. Reciprocal identity. If you know cosine, you know secant. We use the Pythagorean identity to get the sine, and then once we had the sine, the reciprocal identity gets us cosecant. If we know cosine and sine, the ratio identity gets us the tangent, and then the reciprocal identity gets us the cotangent. Okay, so these relationships between the trig functions allow us to take a really little tiny bit of information and get the rest of the stuff that we need.